Hello and welcome to GER Hub Mathematics and Statistics lessons. Today we shall be focusing on the solver series on set theory part 3. Okay, this will be the part 3 video to our solver series on set theory. So let's begin. In a party for 30 young children, 12 were served with Coca-Cola drink while 14 were served with Pepsi Cola. If 9 children were served with Coca-Cola but not with Pepsi Cola, then find, number 1, the number of children served with both drinks, number 2, the number of children served with at least one type of drink, and number 3, the number of children not served with any of the drinks. So let's begin. Now, I'm going to start with interpreting the problem, okay? So I've always advised that children or students should start with interpreting the problem before solving. So let's start. In a party for 30 young children, that means the universal set has been given to you. The cardinality of the universal set has been given to you as 30. Now remember, our definition of the universal set defines the universal set as the largest set under consideration. So the largest set of children considered were the 30 children who attended that party. Okay, now we are told that 12 were served with Coca-Cola. So we will simply say, let C be the number, let C be the children, rather. Let C be the children served with Coca-Cola, okay? Let C be the children served with Coca-Cola. Then what happens? NC will be equal to 12 because we are told that 12 children were served with Coca-Cola. Okay, now let's go over to the next statement. We are told that 14 of them were served with Pepsi Cola. So let P be the children served with Pepsi Cola. Okay, so if we use P to represent the children served with Pepsi Cola, then what would we have? Then NP will be equal to 14. Okay, so what am I doing? I'm trying to interpret the problem, and I would always advise you do so because it helps a lot. Okay, now if 9 children were served with Coca-Cola but not with Pepsi Cola, what does that mean? If 9 children were served with Coca-Cola intersection Pepsi Cola prime, it will give us 9. That is, NC intersection P prime describes the elements found in C alone. The reason why P is carrying the prime is because the elements we are referring to is found in C alone. If it were to be C carrying the prime, it would mean that the elements we are looking for are those in P alone. So those who drank Coca-Cola alone but not Pepsi Cola are 9 altogether. Okay, now quickly you can come over here to make that problem easier for you by putting up a Venn diagram. So it's a 2-set problem. So I would use C here and I will use P here, and I will use this for my universal set. Okay, now take note, we are told that the number of candidates who drank Coca-Cola, that is this whole portion here, is 12. So if this whole portion is 12, what would this portion be? We are told that those who drank only Coca-Cola, this portion here stands for those who drank only Coca-Cola. I'm going to shade it red. So the people here are those who drank only Coca-Cola. Then this portion represents those who drank Coca-Cola and Pepsi. Okay, so I'm going to use this would give you those, if the total who drank Coca-Cola is 12, that is if NC is 12, and those who drank only Coca-Cola. Take note, those who drank only Coca-Cola is different from those who drank Coca-Cola, because those who drank Coca-Cola consist of those who drank only Coca-Cola and Pepsi. Okay, so those who drank only Coca-Cola would be this half moon. Those who drank both Coca-Cola and Pepsi, but found in Coca-Cola are these people here. So this will be 9. Now we want to find those who drank the intersection. Okay, so we don't know. Now let's come to question number 1. We are asked to find the number of children served with both drinks. So for number 1, we are asked to find NC intersection P. Now if you go over to our videos on set theory, you would notice we had described the intersection of two sets to be this, NC, in this case, minus NC intersection P prime. Okay? Because this portion here, if you remember our naming, this portion is NC intersection P prime, and this portion here is NC intersection P. If you add both portions together, it will give you, if you add these two portions, it will give you NC. Okay? So now coming over here, we are given this to be 12 and this is 9. So 12 minus 9 will give us 3, and that answers question 1. Okay? Now for question 2, we are asked to find the number of children served with at least one type of drink. Now take note, in my video on set theory, I told you that statement at least one means one or more, and in set theory it means the universal set, or the union of the two sets rather. So it means we are asked to find C union P, the cardinality of C union P. That's what it means by at least one. Okay, that is, at least one means those who drank one or more. Now that would now be NC, adding NC to NP and then subtracting their intersection will give you that. Okay, so this will be NC, which is 12, plus NP, which is 14, minus NC intersection P, which we have obtained to be 3, and that will give us 12 plus 14, which is 26. 26 minus 3 will give you 23. So the answer to that question is 23. So what it means is that 23 students were served with at least one type of drink, one or more drinks. Now we are asked to find the number of children not served with any of the drinks. Now where would those children be? Remember on our videos on set theory, they would fall in this portion. Those outside this region will fall, but fall in the box will be those who were not served any drink at all. Okay, so that would mean obtaining this C union P all complement. Okay, now remember that the universal set is made up of two portions. The universal set is made up of NC union P and NC union P all complement. Now what we want is NC union P complement, and that will be, when made the subject of formula, N mu minus NC union P. Now what were we told about N mu? We were told that N mu is 30, so I'm going to write here 30 minus the union which we obtained, the cardinality of the union which we obtained to be 23. So our result is 7. What it means is that 7 of the children were not served any drink, and those children will fall here. So they will fall in this portion. Now what have we obtained? Those who drank only Coca-Cola makes 9. Those who drank none at all, 7. Those who drank both, 3. Okay, so those of course who drank Pepsi alone will be 14 minus 3, which will be 11. So that solves the problem. Okay, now let us go to problem number 2. Let's go to problem number 2. Now for problem number 2 on set theory, for problem number 2 on our solver series on set theory, let us see what is demanded. Okay, so we are asked to obtain the following: the number of students that could play football but not volleyball, the number of students that could play volleyball but not football, and the number of students that could not play any of the two games. Okay, now let us look at the question. We are told that a game master of a school called 50 students of the school. So quickly, let's write that down. So the game master called 50 students, mean in the universal set there were 50 students. Okay, now what next happened? After calling 50 students, he selected two teams for the school. So two teams were selected for the school, one in football and the other in volleyball. Okay, now 30 students could play football. 30 students could play football. So let's use F. Let F represent football. So that would imply that NF will be 30. So we are using F to represent the set of those that could play football. Now let's use let V represent volleyball, those that could play volleyball, and that would imply NV is equal to, NV will be equal to 20. So we are told that 20 could play volleyball. Okay, so now the next thing we would go to is the last statement. If 8 students could play both games, let's see what that means. So if 8 students could play both games, then it means we have been given NF intersection V, and that will be 8. So if 8 students could play both games. Okay, now let's see, what are we asked to find? Number one, we are asked to find the number of students that could play football but not volleyball. Let's write that out. The number of students that could play football but not volleyball will be this. Okay, NF intersection V complement, because the set elements we are talking about are found only in football. For number 2, we are asked to find the number of students that could play volleyball but not football. So they want us to find NF complement intersection V, the number of students that are found only in volleyball, not football. Then number 3, we are asked to find the number of students that could not play any of the two games. That is, we are asked to find NF union V, all complement. Okay, now by this side, I'm going to put a Venn diagram here to guide us. Okay, I always emphasize the use of Venn diagrams because it is a very useful tool that guides you in solving your problems easily. Now let's see. So let's fix what we have been given. We have been given this to be 8, okay? Because we are told that those who play football and volleyball, 8, are made up of 8 students. Now, if this total, those who played football altogether gives 30, then this portion, the half moon, will be those who played only football, and that will be 30, the total portion, minus 8. And 30 minus 8 gives 22, okay? Now, this other portion here, this other half moon, is the portion that played only volleyball, and that will be the total that played volleyball, 20 minus 8, giving us 12, okay? So, now, if you want to know those that are here, all you would have to do is to subtract 22 plus 8 plus 12 from the universal set. Now 50 students were called for those games to be partitioned into football and volleyball teams. Now if you add 22 to 8, it will give you 30. 30 plus 12 will give you 42. Okay, so this will be 50 minus 42 students, giving you 8. So 8 students were not put in any of the teams. Okay, they did not play both football. They did not play football, neither did they play volleyball. Okay, so let us see. Now that we have done that, we can now go back to the problem. Remember, the Venn diagram has made the problem easy, so I'm going to start with number 1. I would advise you to use set builder notation when solving. It's always advisable, okay? So this will be equal to what? Now, we would use this relationship to obtain our result. Take note, NF, the number of those that played football, is made up of two partitions, NF intersection V complement plus NF intersection V. Now, what are those portions? This portion is this. This portion here is this, the half moon, and this is the portion, the unshaded one. Okay? So if you add those two portions together, they will give you F. Now, what do we want? We want to find this. What are we given? We have been given this to be 8, and we have been given this to be 30. So if you make NF intersection V complement the subject of formula, it will give us 30 minus 8, and 30 minus 8 is 22. Okay? And that solves problem 1. Now, if you go to problem 2, NF intersection V is equal to what? Now, take note, NV can establish that relationship for us. So, NV is made up of NF intersection V with F carrying the complement plus NF intersection V. Again, this is the portion here. This remains this portion. Okay? This is still the portion we are talking about. And this portion here is this. The half moon. Okay? And that would mean adding both of them gives NV. It will give you the whole of V. If you add this portion to this portion, it will give you the whole of V. Okay? So that would mean NV, which has been given to us as 20, is equal to NF prime intersection V plus NF intersection V, which we were given as 8. So if you make NF prime intersection V the subject of formula, you're going to have 20 minus 8, which is 12. Okay? Then for number 3, you have NF union V complement. So how do we obtain this? I'm going to put a question mark there. Now, take note, we can obtain it from this relationship. If you go to our videos on set theory, you will notice that we had this. The universal set is made up of, this was supposed to be NV prime, okay? So the universal set is made up of NF union V plus NF union V all complement. So if you add the complement to this, it will give you the universal set. Now come over to the Venn diagram. If you add the portion here, this portion outside the circles, to what is contained within the circle, it will give you the universal set. That is what it means. So what do we have as NF union V? Now NF union V, if you remember, is obtained by adding NF for two sets to NV and subtracting NF intersection V. So this whole thing will give you NF union V. Now when you add that to NF union V all complement, which we want to look for, it will give us N universal set. Okay, the cardinality of the universal set. Now, what were we given as the universal set number? 50. What were we given as NF? We were given 30. What were we given as NV? We were given 20. What were we given as the intersection of both? We were given 8. Now, we want to find this. All complement. Now, 30 plus 20 will give you 50. 50 minus 8 will give you 42. So we have that 50 is equal to 42 plus NF union V all complement. And that implies that NF union V all complement will be equal to 50 minus 42. And that is 8. And that solves the problem, of course. Okay? So, please, I would advise you to go over the video, watch the video again and again. It will make you see clearly what we have done. Now, let's go to question number 3. Okay? let's go to question number 3. Now for question number 3, what are we asked to do? Now let's read question number 3 together. So a survey was carried out on 40 travelers. So quickly, a survey was carried out on 40 travelers means that in the universal set there were 40 travelers. So I'm going to use this. The cardinality of the universal set is 40. Now 12 of the travelers said they had traveled to Ghana. Okay, 12 said they had traveled to Ghana. So let G represent Ghana. And that would mean, if G represents Ghana, that would mean the number in G will be 12. So, but, okay, 12 of the travelers said they had traveled to Ghana, but not to Cameroon before. Okay, so that alters this statement, and we are going to write that statement again. So if G represents Ghana, let G represent Ghana, okay? Now, let C represent Cameroon. Let C represent Cameroon. Then, what it means is if 12 said they had traveled to Ghana but not to Cameroon, then it means NG intersection C, with C carrying the complement, because they had not traveled to Cameroon, they had only traveled to Ghana, will be 12. This will be 12, okay? Now, 8 of the travelers claimed they had traveled to Cameroon but not to Ghana before. So it means NG prime intersection C will be equal to 8. They had traveled to Cameroon but not to Ghana. That's why Ghana is carrying the prime, okay? Now, 10 of the travelers said they had not traveled to any of the two countries before. So NG union C, all complements, said they've not traveled to any of the countries before. That's 10, okay? Now, the question says, draw a Venn diagram to find, number 1, the number of travelers that have traveled to both countries before. So I'm going to draw a Venn diagram here. This is the universal set. Then I'm going to put my oval shapes or circles to represent G and C. Now, quickly, what do we want to find? Let's interpret this first of all. Now, those who had traveled to only Ghana, 12. Those who had traveled to only Cameroon, 8. Those who did not travel at all, 10. Okay? So those who had not traveled to any of these countries fall outside the union of these two countries. And that's why I'm putting 10 here. So we want to find, number 1, this portion. We want to find this portion. So let's see how that is done. Now, the number of travelers that had traveled to both countries is NG intersection C. That's what we want to find. But if you remember vividly, you will notice that N mu, the universal set, the cardinality of the universal set, according to what I explained in set theory, our videos on set theory, gives you G union C plus N G union C, all complement. Okay? Now, this G union C can be decomposed to NG plus NC minus NG intersection C plus NG union C, all complement. And this will be an alternative to writing the universal set. Now, we are told the universal set number was 40. Those who, we were not given those who, who had traveled to Ghana. We were not given those who had traveled to Ghana. So what we are going to do here is to write out what we have been given. So I'm going to write here N Ghana plus NC, okay, minus NG intersection C is equal plus what we are given. We are given this to be 10. So NG plus NC minus NG intersection C is equal to 40 minus 10, which is actually equal to 30. and that implies that the union of these sets will give us 30, because all these would make the union NG union C. So NG union C gives 30. Okay, so what we are interested in is obtaining this, the cardinality of the intersection. So let's see. Now what do we do? What do we do? Now take note, in this case we can actually start decomposing. We can actually decompose, and let's see how that is done. So if you have NG, remember, if you have NG and you have NC and you subtract the intersection, it will give you the cardinality of the union. So now that we have, let's write out what we have now. We now have the cardinality of the union to be 30. Okay, that is everybody in this set is 30. Now let us decompose. So I'm going to write this NG union C is equal to NG intersection NG intersection C complement plus NG intersection C, and this will represent NG, okay, plus NG complement intersection C plus NG intersection C, and this would add up to give you NC. I want you to verify this and understand what is actually going on. Then the final shall be added to, okay, we will now subtract whatsoever we get. We will now subtract the intersection, which we really want. Okay, so now let's see, based on this decomposition, based on what I am doing here, let's see what happens. So it will mean that NG intersection C, NG union C, which is 30, will be equal to this, which we were given as 12, plus NG intersection C over there, this one here comes down here, okay, then plus NG prime intersection C, which we were given as 8, plus NG intersection C, then minus NG intersection C. Okay, now this minus this will go, leaving us with 30 equals 12 plus NG intersection C plus 8. So NG intersection C, if made the subject of formula, will be 30 minus 12 plus 8, which is 20, giving us 10. So it means that the number of candidates in this set, this portion of the set, is 10. Now take note, if you add 12 to 8, it gives 30. It gives 20. 20 plus 10 gives you 30, which is actually the union of the set. Okay. Now let us go to question number 2. Question number 2 says, question number 2 demands, remember, that we find the number of travelers that had traveled to Ghana before. The number of travelers that had traveled to Ghana before. So the number of travelers that had traveled to Ghana before is NG. And NG is what we want to find, but NG is made up of NG intersection C complement, that is only G, plus NG intersection C. So if you add those who had traveled to Ghana only, which is NG intersection C prime means that what we are referring to is found only in G. Now, if you add this set to this set, it will give you G. Since we want those who had traveled to Ghana before, then we are going to have NG equals NG intersection C prime was given to us, remember, as 12. So we're going to bring 12 here. And now that we have obtained NG intersection C to be 10, we bring 10 here. The result gives us 22. and that ends the problem. So try to understand what we've done. Look at the video, watch the video again, and you understand clearly what we have done. So thank you very much for listening. Right, like our videos. Of course, if you like what we are doing and you want to support the channel, keep liking our videos. Click that like button. If you want to support us, watch our videos, and also most importantly, share our videos and subscribe to the channel. Keep your subscriptions coming. It encourages the channel to grow, and I'll see you in a bit. Thank you.